Okay, in this video I'm going to continue on with exercise 5b of the book Fundamental Applied Mathematics. We're on page 131 and the question is 8. It reads, the diagram shows a horizontal table on which masses of 2, 4 and 10 kilos are placed, or 2 and 4 kilos are placed. Masses of 10 and 1 kilos hang over the sides by means of a string which passes over smooth pulleys. Find the common acceleration of the masses. Okay, so the first thing we need to do is draw our free body diagram. So we have kind of a sketch of the diagram. Now we put in our forces. So I'm going to push through this pretty quickly. If you haven't watched my video on the massless rope, please watch that. If you haven't watched my video on Newton's third law, please watch that. And if you haven't watched my video introducing the pulleys, the vectors for pulleys and ropes, please watch that too. So we'll just pop straight into this. So this is going to be minus 10g j hat, because look at my unit vectors and my gravity vector here. Alright, this is going to be negative g j hat, this is going to be negative 2g j hat, and this is going to be negative 4g j hat. Now for every action there is an equal but opposite reaction. So on these tables, these are the forces of the table, we'll say the masses on the table. Now we need the force of the table on the masses. So we have an opposite direction and its magnitude is the same, so it's 2g j hat, and this is 4g j hat. Now we need to look at the tensional forces. So the tensional forces are here at T1, here at T1, here at T2, here at T2, here at T3, and here T3. Now it's important to note that these are not Newton's third law pairs or action-reaction pairs. They are in fact due to the fact that the rope is massless and inextensible. Now we're told, oh yeah, initially the table is smooth. So that means that there are no frictional forces on the table. So what I'm going to do now is just go ahead and apply Newton's second law. So Newton's second law states, of course, that the sum of the forces is equal to the mass times the acceleration of an object. So what we're going to do initially is start with number 1. Now I know this might get cluttered for a while, so just bear with me. So this is for the 1 kilo mass. So the sum of the forces is T3. Oh, excuse me, we need an acceleration. We need an acceleration vector somewhere. So it doesn't matter. I'm just going to say that if we're going, this is negative a j hat, this is a I hat, and this is a j hat. Alright? So anyway, for mass number 1, it's going to be T3 j hat minus g j hat is equal to a j hat times 1. Alright, so I'm going to call this equation 1. So T3 minus g is equal to a, and this is all in the j hat direction. Alright, so that was pretty straightforward. I'm going to do the same thing for the 10 kilo mass now. I'm going to call that equation 1. So the 10 kilo mass, it's going to be T1 j hat minus 10g j hat is equal to negative 10a j hat. So just rearrange that. We're going to get that equation 2 is T1 minus 10g is equal to negative 10a, and this is all in the j hat direction. Next we'll do the 2 kilo mass. Now of course, if we're doing all the sums, we're going to get j hat vectors, but look straight out that these cancel out. We have negative 4g j hat plus 4g j hat, and they'll just cancel. So I'm only actually going to look at the I hat direction unit vectors. So what we're going to get is that T2 I hat minus T3 I hat is equal to 2a I hat. Okay, notice this is negative I hat, this is positive I hat. So we're going to get equation 3 is equal to T2 minus T3 is equal to 2a I hat. Alright, of course you've got to put in the j hat vectors if you like, but in the end they would just have cancelled out. So we're going to finally look at the 4 kilo mass, and we're going to get that T1 I hat minus T2 I hat is equal to 4 times the acceleration times I hat. So we're going to get equation 4 is equal to T1 minus T2 is equal to 4a, all in the I hat unit vector direction. Alright, so we're doing well. Now what I'm going to do is I'm not going to get rid of the diagram because we're actually going to use that in the second part of the question. Alright, so I'm just going to push this up here, and we're going to start like that. So we're being asked to find the common acceleration, so you want to get rid of everything. So if you look, we can get rid of T3 here because we get T3 in terms of A and G. We can do the same with T1, and we want to be able to do the same with T2 here. So as a result, we're going to be able to get everything in terms of A and G. So let's just start off with equation 1. We're going to get that T3 is equal to A plus G, and I'm going to call that equation 5. If you look at equation 2 here, just rearrange that, you're going to get a new equation which I'm going to call 6. It says that T1 is equal to 10G minus 10A. Alright, now look, you can also put in the unit vector directions. However, at this stage, because all of this is in one direction, so is all of this, this, and this. They're just numbers, so you can leave out the directions to this stage. Obviously, if there was an I hat and j hat component, you couldn't do that. If we look at equation number 3, we find T2 in terms of T3 and A. So we're going to get 7. We're going to get that T2 is equal to 2A plus T3. But we already have an equation for T3. Alright, so let's put 5 into 7. You're going to get that T2 is equal to 2A plus G is equal to 3A plus G. So T2 is equal to 3A plus G. Alright, T2 is equal to 3A plus G. Yeah, okay. Now what we need to do is we have each of the tensional forces in terms of the acceleration and gravity. So if we plug them in down here, we're going to get everything in terms of acceleration and gravity and A. Alright, so we're going to put equation 6 and equation 7 into equation 4. So you're going to get the T1, which is 10G minus 10A, and we're going to get minus 3A minus G is equal to 4A. So that's 7A over here. No, it's not. It's actually 17A. Alright, 17A, yeah. And here it's going to be 9G. So A is equal to 9G over 17. So let's just find out what that is equal to. 9G, that's 9 times 9.81 divided by 17 gives an answer of 5.19 meters per second squared. Now what I'm going to do is I'm just going to check that at the back of the book. So on 5b, question 8, 9G over 17, yeah, that's correct. And we should get 6G over 17 for part 2. So that's correct, right? Now, the second part of the question asks us to do the same thing, but this time with a frictional force. So if we just go back up here, what can we say up here? If there's going to be a frictional force, then it's going to be going in this direction and this direction here. The frictional force, we should know at this stage, so that frictional force is equal to the normal force times the coefficient of friction. So for mass number 1, or sorry, for the 2 kilo mass, the frictional force is going to be equal to 2G times the coefficient of friction, which we're given as a half, so it's going to be equal to G. And that's going to be equal to negative G I hat. And for the 4 kilo mass, the frictional force is going to be equal to 4G over 2 is equal to negative 2G I hat. Alright, so all I'm going to do is plug these back into the equations which you already made, just to make it a bit quicker. So this is equation number, so we're talking about T2, this one here. So it's T2 minus T3. So we need, one sec now here, let's plug this in here. So it's going to be T2 minus 2G I hat minus T3. There. And for the 4 kilo mass, which is here, we're going to have T1 minus T2 minus 2G. This is actually just G. So it's going to be T1 minus T2 minus 2G. There. Alright, so this time it's going to be the exact same procedure, and we'll see how we get on. So I'm going to put equation, well, from equation 1 we're going to get equation 5. So let's renumber these. So we're going to get that T3 is equal to A plus G. We're going to get that from equation number 2, we're going to get that T1 is equal to 10G minus 10A. Alright, so we're going to put, we have T2 in terms of T3. So if I put equation 5 into equation 3, we're going to get T2 minus G minus A minus G is equal to 2A. Therefore T2 is equal to 3A minus 2G, or plus 2G. Is that right now? 3A plus 2G. So we're going to get equation 7, T2 is equal to 3A plus 2G. Alright. Now that means we have each of the tensional forces in terms of the acceleration and gravity. So let's plug those into equation 4. So we're going to go for 5, 6, 7 into equation 4. And you're going to get T1, which was 10G minus 10A, minus 2G, minus T2, which is equal to minus 3A minus 2G, is equal to 4A. Alright, so let's just rearrange this. We have a 10A and a 3A, which is a 13A. Is that right? 13A, so this is going to be a 17A. And we have a 10G minus 2G, which is 8G, minus 2G, which is going to be 6G. So we're going to A is equal to 6G over 17, which is correct. Alright, so that was pretty straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.